problem, it says let n be an integer such that 5 is less than n is less than 50. Determine the probability that for a randomly selected value of n, the value 2n plus 1 is not a multiple of 3. Express your answer as an integer or as a common fraction. Now it says that n is an integer such that 5 is less than n is less than 50. So the smallest value of n in this problem is 6. And it could go all the way up. So let's see, 9, 10, 11, 12, 13, dot, dot, dot. Now, n is less than 50. So the highest that it can go is 49. So, just put 49 down there. Way down there. All right. Now, looking at this list, from 6 all the way to 49, it's good to ask, well, how many are on this list? So what we do is we say, all right, well, we have 49 numbers because it ends at 49, and then we subtract 5. Because if you just say there's 49, that means it would go from 49 all the way down to 1. But we have to exclude 5, 4, 3, 2, 1. So there's 44. So there's 44 total numbers in this whole list. And that'll be important for us in a bit. Then it says the value 2n plus 1. So 2n plus 1. All right. Well, if n is 6, 2n plus 1, 2 times 6 plus 1 is 13. Then 7. 2 times 7 is 14, plus 1 is 15. For 8, 2 times 8 is 16, plus 1 is 17. Notice a pattern here. Here this is n, and these values go up by 1. This is 2n plus 1. These values are going up by 2. So that means we can take advantage of that and say that this will be 19, 21, 23, 25, 27, and so on. Okay. Now, this could be a big time suck because we could take a whole long time writing out every single possible number. Now, let's see what the question is asking. What's the probability that this number, 2n plus 1, is not a multiple of 3? Now, what is actually a little easier is to say, all right, first find the numbers that are multiples of 3. Well, you got 15, you got 19, whoops, not 19, but 21, 27, and so on. Now notice how often they happen. They happen every 3 numbers. Okay? So, if I take 44 and divide that by 3, because it happens every 3, then I get 14 and 2/3. So the question is, do I get 14 or do I get 15 numbers? And that's why I put this 49 down at the bottom of our list. So, if we have 49, what is 2n plus 1? And that value is 99. Now, is 99 a multiple of 3? Yes, it is. So why did we get 14 and 2/3? Well, if you notice, this list, if I group these numbers like this, they kind of go in a pattern. 2 numbers that aren't multiples of 3 with a number in between. And then 2 numbers that aren't a multiple of 3 with a multiple of 3 in between, and so on. Well, there are 14 of these groups in this set, if we counted them all out. Now, where the 2/3 come from? Came from here. If I look at the bottom of my list, let's see, 47, 48, 49, 95. These 2 are part of an incomplete group, whereas the 95 is part of a complete group. And so this is the 2/3 of a group. All right. And so the number that are multiples of 3 is 15, because we got 1 in each whole group, plus we got 1 in this partial group. So that's 15 out of 44. But that's not what we want to know, because this is the probability of those that are a multiple of 3. We want to know what's the probability of those that aren't a multiple of 3. So we take 44, subtract 15. And that gives us 29, which tells us if we counted up all these numbers, there would be 29 of these numbers that aren't multiples of 3. So 29 over 44 is our answer, and we're done.